Welcome everyone to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin. I am the astronomer for the Rancho Mirage Library and Observatory. And here we are. Yes, we're actually going from inside the cosmic office today because, well, it was hot enough outside just setting up the telescopes, and we want to survive the night. So we are ready to start looking at stuff out in the night sky. And we were very fortunate today because we had quite the actual development of the weather here. If we actually start in the morning, we actually had quite a bit of clouds, but those actually all burned off, which was very fortunate for us, as you can see, and eventually just stayed nice and clear. So we're very fortunate in that regard, and we actually have some good views right here. In theory, some things will actually be starting up here. All right. So, actually, let's just jump right over to this view here. This is our small telescope view, and the reticle is not telling you much right there. But we are here for the conjunction of Venus and Mars, and it might be hard to notice, but they are actually both in this field of view right now. We'll come back to this a little bit more later. If we're looking at this view, Venus is down in the lower left right here, while Mars is hanging out in the upper right. It's very dim at the moment right up there. So if I actually adjust some of our exposure settings, we can make that more distant planet pop right out. There's that red planet. Of course, when you overexpose Venus, you can see Mars quite well at that point. Now, I'm jumping right into things because we've got relatively limited amount of time. We'll come right back to this view, but yeah, if we're looking at our Stellarium view, if we were set up in the center spot on our deck, we would be about ready to lose our view. We are not set up on the center of the deck. We are actually set up over on this pad over here, which gives us a little bit better view of this part of the sky. And so we'll be able to look a little bit longer than the next few minutes, thankfully. Now, again, jumping right into this, worth noting a few things, including my apologies, Lauren. I'm being helped out tonight by Lauren Zuckerberg, our Observatory Programs Coordinator. Got you unmuted right now if you want to say anything.
Hello, everyone. Hope you're having a great evening.
Yeah. So where is Venus? I see has a question right there. Venus is towards the southwest right now. If you can spot the moon, it's going to be near that. And thankfully in Stellarium, I can turn off the ground here so we can see a bit more. If we want the exact location of Venus, it is hanging out at a compass heading of 278 degrees. So actually it's just about due west. So yeah, it's a little bit north of west if we're actually looking carefully there. Now again, Mars and Venus are right near each other, and if you're looking right now from anywhere near the observatory, you might have a little bit of trouble spotting them because the sky is actually still quite bright. So give it a little bit. If you're away from the mountains, you'll be able to spot them a little bit better at that point. Now, other questions about where is Venus? Well, Venus is actually right now about twice as far away from us as it is from the sun. It's about it's a little bit under 3/4 of the distance from the Earth to the sun. It's about 3/4 of that distance from the sun, but it's about, therefore, 1.5 times the distance between the Earth from the sun away from us right now, at about 1.4 AU. Astronomical units, again, is the definition of the distance between the Earth and the sun. It's really an average, though. Let's see. All right, so, of course, while we're looking at these things, let's jump back over to our small telescope view, where you can again see the two planets hanging out. One right down there, Venus, and Mars, that little tiny fuzzy guy right there. And let's see if we can't actually bring out that view of Mars right now. Let's actually lock in on it. Hit this, and there is just what we're dealing with. That little dancing that's going on there will be due partly to our best efforts at focusing, but also the actual atmospheric disturbances going on in the atmosphere. Nevertheless, you can see that reddish color. there is a little bit of a color distortion that will be due to a few different things, including the atmosphere and just the actual processing of the telescope, right now the camera on it. So great to get a nice good close view of Mars. Let's switch back over here and go back over to Venus, because I want to mess around with Venus a little bit, because Venus is a bit brighter, which allows us to do some nice things. We did our best with the Batinov mask earlier, and here you can see that that color aberration going on there, chromatic aberration done specifically for a number of different things, but at this stage in the atmosphere, that will be partly due to the refraction of the light in the atmosphere. So yeah, we are way overexposed for looking at Venus, so if we dial that down in exposure time, we can start to see a bit more going on there, and eventually you really see a lot of just shimmering there. And that is what happens when you're, well, as focused as best you can, but dealing with an object like Venus that is much further away from us than the sun is right now, 1.4 AU. And we're also looking low in the sky, and the weather's been not great for stargazing in general. So anyway, other thing to note is just how far away it is. Sorry, I'm all over the place. It took a lot to get everything set up today. But our view of Venus right now is that of a, I believe it's at a gibbous phase. Oh, I left that pointer on there. I apologize. I want to say it's at a gibbous phase, so it's not a crescent, which means we won't be seeing much shape detail in Venus. And Venus is also a cloud-covered place, and so we won't be seeing any surface detail here. We generally just see a bit of a cream color to Venus when we're looking at it. Let's jump all the way back to our full view here, adjust our exposure time to see both planets. There we are. Okay, so let's see. I'm going to adjust our exposure time a little bit more. Pull that up here. There we go. Now we can see both of them really clearly. All right, so what makes a conjunction special? Well, a conjunction is really just a crazy random happenstance of two objects aligning in our sky, which technically means that three objects have aligned, the Earth and these two planets, in a nice line. This is a generally referred to as a syzygy for the most general alignment of three bodies in space. And so how can we actually get an understanding for this? Well, let's go ahead and hop over to Space Engine, where we can actually explore some of this a bit more directly. Now, you might think, oh, those two lights out there, those are our two planets. No, we have such a large field of view in this view right here that is actually the moon up higher and our two planets right down here. So let's go ahead and zoom in on this view here. And this, will tell us just what we're looking at for our phases on Venus. All right. Yep, nice gibbous phase on Venus there, as mentioned. So it's nearly circular, so it's a little bit hard to actually spot a few things. But let's go ahead and explore this setup in a bit more detail. And as we're doing that, you might notice right beneath me, our main telescope is sitting there. It is not currently looking, but let's go ahead and change that. And to change that, we need to start by opening the dome, which, let's see, I need to make this field of view a bit bigger. There it is. Now, if you look right beneath me, you'll see that shutter opening. The top section slides over the back of the dome while the lower section folds out. And so it'll be about 3 minutes for that to get going. As that goes, the blower system turns on right now, which is pumping outside air into the dome to actually equalize that temperature, which helps with a bit of distortion there. And so while that's going, let's go ahead and continue our simulated exploration here. And so to really simulate this, let's go ahead and, wrong button, hit this button. There we go. Fly out of the Coachella Valley, way off the Earth. And let's go ahead and switch on our orbit view. We want to be aligned with these orbits now. And let's go on up here. There we go. So from here, we can start to see what we're talking about when we talk about a syzygy that line, set of 3 lines there. See, I want this button here. And so we are down here at the Earth. And if we extend a line right out here, you can see we connect all 3 of the planets in a straight line, thus making a line that we would refer to as a syzygy, that alignment. But in general, we can, from our point of view, we refer to it as a conjunction, these 2 objects being viewed together in the night sky. So where we're looking at here is we are looking in a top-down view of the solar system. And with this top-down view, we can actually consider how everything's moving in their orbits. We are moving in a counterclockwise fashion from this view around the sun, and the speed at which objects move around in their orbits is dependent on how close they are to that object and the mass of the object. And Kepler's third law is great. I would go into all the detail if you let me, but I'm going to restrain myself from that. But when we're looking at that note, when we compare 2 objects, say Venus compared to the Earth is moving slower around the sun than Venus is. So Venus is in the process of catching up to the Earth. And in contrast, when you compare the Earth and Mars is moving slower in its orbit around the sun than the Earth is. And so Mars is slowly falling further and further behind. And so in our sky, we've been watching Venus catch up to Mars in the sky, and Mars will fall behind. So if we go back over to Stellarium and see our objects there, let's see, there we are. So if we're looking here and turn on our orbits with that, we can actually see that Venus here is catching up to us, so it's moving this direction, while Mars is falling further and further towards the sun. And so while we're looking up in the night sky, we'll get to see a lot of interesting things. Now, this curve here will be Venus's orbit, and so Venus will get a maximum distance away from the sun, while Mars, because it's on the outside of the Earth's orbit, it doesn't have that little arcing point. It doesn't arc back towards the sun. That stripe will actually go all the way around the sky if we were able to follow it, but since this thing wants to hide that from us, it won't. Anyway, back over to Space Engine for a quick other note. Excuse me. While we're looking at these 2 objects, Mars doesn't get much smaller in our sky than it is right now. Venus also can only get a little bit smaller, but Venus can get dramatically bigger in our sky, and that's when it moves down around, pointing with the wrong thing here, down around this arc here. As it moves down around that arc, it will actually get a lot closer to us, and it will be better resolved, but it will move into a crescent phase. And so what we're looking at right now is a waning gibbous, but as it moves into that crescent phase, it still becomes brighter because of how much closer it's getting to us. And that was one of Galileo's important observations there. Now let's see, we've got a few things going for us right now. Let's go ahead and switch over to our combo view here, where we can see all the different things going on, the exception of our specific angle on a few things. Now, in that upper left view, we don't see much right now. That is actually our main telescope, which again, we've only started opening things up. We need to actually open up the petals that cover the mirror, so we're going to open those right now. And so if you look directly beneath me, you might see a couple little things popping up right around the mirror. That is, if everything is cooperating down there. Yep, there they go. Great. Let's see. Let's see what we get from another angle here. Yeah, that doesn't really show us all that much more, but you can still see that petal right there opened up. Now that that's opened up and everything's working, you can actually see on the far side of the screen from me over here, this is our planetary camera, and it has actually started shifting a little bit in color. Let's see, give me this one. All right, so let's go ahead and adjust a few things here. Maybe we can make it a little bit nicer. I need to stretch it this way. There we go. Okay, and we don't see anything right there right now. Well, that's because the telescope hasn't been pointing at Mars or Venus yet. So let's see if we can't get over to Venus. Dealing with a very small representation of the screen over there. I could easily slide back over to that thing back there, but I'm just going to look right here. There we are. All right, let's send it over there, and we should see things start moving down below. There goes the telescope. Oh, it's thinking a little bit too hard. Make sure we're still good there. Okay. And we want the dome to make its way over there. It will, but it's going to take a few seconds to figure things out. There it goes. All right, so hopefully we are actually on a good target. Yep, yes we are. There's Venus. All right, let's see. Oh, that over there. Oh, can you go and grab the controller for me? I forgot to grab that. Thank you. All right, while Lauren goes and grabs the controller, we can adjust our exposure time here. And yes, Ron is correct. This is what Venus looked like about 12 minutes ago, because that's how long it takes that light from Venus to reach us. And so this is what it looks like when you have it a bit overexposed. Anyway, let's go ahead and turn off that gain, and let's see if we can't do anything a bit more here. Let's see. Oh, that's the wrong direction. That's the right direction. There we go. All right. The telescope is also doing some rotation, which is going to make controlling this exciting. And it's making it wander all over the place for us. Yama. Yama. If you've ever been to stargazing, this little bit of motion does just happen. And most of the weird motion going on right now is going to be due to the derotator. It is something that actually rotates the camera. And it looks like it might have actually settled in for us right here. Yeah, I'm just going to stop that action right now. Good. And unlike the little telescope, which we have to do a big song and dance for focusing, the big telescope we can actually focus right here. And so let's see if we can't get any better of a focus. I get the feeling we probably won't, just because we are getting low in the atmosphere. We actually just dropped below 15 degrees, which is near the point where the big telescope is going to give up on us, saying that's too close to the horizon, and it won't bother doing much else. That's why we have all that chromatic aberration again. That's not what I want to see. Go the other way. Yeah, we're only going to be able to do so much here. Let's see. Yeah, you can see it trying to come into focus, but that's mostly due to the atmosphere. Sometimes it gets nice and clear, and so we get this big dancing motion going on there. Now let's see. I bet it's going to say, no, I'm not going to Mars. It's too close to the horizon now. But let's go ahead and see if it will cooperate with us. Oop, it's moving. Now, Mars, of course, we're going to need a very different exposure time for. So let's just start by cranking up the gain, see if we get a nice view of Mars in here. I'm not seeing it yet, so that's not necessarily a great sign that we're going to land on it with that telescope right now. Let's see. Try going back to Venus. Will it land back there? I'm getting the feeling that the telescope is about ready to give up on us. Yep, it just gave up on us. All right, so that was our view of the view through the big telescope. It was worth a shot. Again, everything we're doing right now is very just on the cusp of what we can do because of where this happens to be in our sky. Once again, this is our small telescope, which actually is able to get a little bit lower with Venus right there and Mars right up here. Let's see. Hi, Jennifer. Glad to have you here. All right. When our stargazing night's going to start up again, we're hoping to do them as soon as possible, but among the things that has to happen is first, things not only needed to get safe in general, then we need to actually bring in our docents and retrain to make sure everyone's actually up and ready to be able to help with all these stargazing events. And we also aren't at a point where everything is perfectly 100% safe, so we need to actually have specialized safety measures in place. After all, people are literally putting their eyes up to the same object, and so we need to have some very specialized protocols for making sure everything is safe. We are expecting to be starting our stargazing up towards the fall, which is especially nice because Lauren and I don't want to be outside right now. It is very hot, and so it doesn't seem like the best time to start up stargazing right when everyone's going to get heat stroke. So we're going to hold off a little bit until it starts to cool down, hopefully. But as much as I want to be out there right now with all of you, this is the best way for us to do it in a nice, safe way for more than one safe reason, especially since people need to get reacclimated to being out at night in the heat. So let's see. But excellent question, Steve. I appreciate that. Now let's see. All right, while we're looking back at this view here, we are again going to swap over to our Stellarium view just to get another feel for what we're actually looking at here. If we zoom back in on these two objects, you can see just how close they are in the sky. I believe, do I have that turned on here? I don't. Of course, I don't have that extension turned on. There's an angle measuring extension, which would give me the exact distance between them right now. They are getting around a half a degree apart, a little bit under at their closest point, which they should have, or they should be just about to get to. Because again, if we look at both of their orbits, they are moving along these orbits here. Over time, we see Mars moving this way and Venus moving that way. So we are very near that actual closest approach. When it comes to conjunctions, it's always hit or miss whether or not you actually get to see the moment of closest approach. So we're getting really darn close here. So we're in a good spot there. Now, the planets themselves are very interesting ones. In case you aren't familiar with a few things, we got some nice facts and figures to go over here. This is actually a couple of slides from an old couple of talks I gave, one on Venus and one on Mars. And it's always worth going through and noting a few things. Yep, Venus does end up being the second brightest object in the night sky after the moon. It actually competes with being the second brightest with the International Space Station, but Venus right now, it actually is around a -3, I think, between -3 and -4 magnitude, which is it's -3.8, which is very bright. Negative numbers in magnitude means brighter, but again, it is very similar to Earth. However, because it's closer to the sun and because of a few other factors, it is very unlike Earth in other ways. It is very similar in size and mass. It's just ever so slightly smaller, but it actually has a very thick layer of, or a very thick atmosphere, which actually is incredibly high pressure at the surface. Atmospheric pressure down there at 92 times what we're experiencing here, and it's like going nearly a kilometer under the surface of the ocean. It is punishingly crushing. That combined with those surface temperatures that are hot enough to melt lead at about 460 degrees C, and again, that's an average over the entire planet. There are areas that will be hotter, there are areas that will be a little bit cooler, but that's the good average there. It is extremely hot, which makes it very hard to do anything there. So we want to be very careful if we're ever exploring there. And among the things that go on there include the fact that there's not really a magnetosphere there. There's not this protective magnetic shield that the Earth has, which collects a lot of incoming particles that would otherwise strip away material from the atmosphere. Some stuff does get lost from the Earth, but a lot less than otherwise would be, as evidenced by what goes on at Venus. And as noted here, one possibility for where Venus lost its water is that it got photodissociated in the atmosphere, and hydrogen was very easy to get carried away because it's the lightest atom. Now let's see. Before we go on to Mars, always good to check back in over at our small telescope view. Once again, let's go ahead and brighten things up because I want to see Mars really nicely. Let's see. Oh, that is a long exposure right there. That is around, around 0.6 of a second. Let's go ahead and hop in over at Mars. Make that bigger. There's Mars. And let's see. Go ahead and cut down that exposure time a lot. Actually looking a little bit clearer than it was earlier. And let's try doing some live stacking here. See if we can't get anything even nicer there. Let's go ahead and cut down that exposure time even more. There we go. That's a good looking little view of Mars there. Again, we didn't get quite perfect focus, but we came pretty darn close with that one. If you're expecting this to be a picture-perfect view of Mars, we live on Earth and the atmosphere is in the way. And as a reminder, back over here, we are further away from Mars than we are from the sun. We're actually about almost 2.5 times further away from Mars right now than we are from the sun. It's a long way out there. So what can you expect to see when you're looking at Mars right now? Yeah, this. This is what you actually get a good view of. Now, okay, that is all well and good. Let's go ahead and hop back over to this view where we can see both. Now that we're doing some live stacking, got a good view showing both of those planets quite nicely. There and there, yeah. So let's hop in over on Venus real quick one more time before I talk in more depth about Mars. As Ron noted, we do have a helicopter on Mars, which is a great achievement. Let's go ahead and dramatically reduce that exposure time. See what we get here. Yeah, we're getting some, but not exactly what we want. All right, let's stop that live stacking here. In fact, actually, I changed my mind. Let's do more stacking. Let's get like 25, 24 frames, but get really short exposures. See if we get anything out of that. You can almost see a gibbous shape to it. Almost. Not quite. Anyway, back to the full view, and let's go ahead and turn off the live stacking. Where'd it go? Well, it's still there. Let's just crank up that exposure time. There it is. And show me the whole view. The whole view? That button. Then the whole view. There we go. All right. Make sure we don't lose Mars here. So let's crank up our exposure time once again. All right. There's everybody. Now again, you might notice this is a rather different orientation of things relative to what we were looking at over in this view here, because what we're dealing with is a bit of a mirroring going on in the telescope that flips your views, and the actual angle at which everything is positioned in the telescope leads to this setup here. Anyway, let's see. All right. Yeah, if you're looking close at it and you got a good view, it might look like a double star right now, which is always a cool thing to see. There's a few optical doubles out there that are really good for spotting with the naked eye or with telescopes. There are optical doubles, and then there are binaries. There are binary stars out there that actually orbit each other, but when you can resolve them, typically they actually aren't orbiting each other, but there are a few exceptions. Those are always worth hunting down. These two objects, they look like a double star in the sky. They're definitely not orbiting each other. They're orbiting our own home star, the sun. Now let's see. Let's go ahead and jump back over here. I wanted to touch base on a few things with Mars. Mars is the fourth planet from the sun. Again, as you saw in the other diagram, it's further out than we are. It's the second smallest after Mercury, and it's named for the Roman god of war, while Venus is named for the Roman goddess of love. And what's cool about Mars is that red color that we see is actually the result of there being a lot of ferric oxide, iron oxide, that literally rust all over the surface of that planet. And it has completely colored it to the extent that we can see that color from here. That surface gravity there is, in fact, about 38% of what we have here. It's notably a lot more than what you get on the moon, which is around 16%. But still, it's so low that you could have quite a fun time getting around there, we'll say. What's interesting is the atmospheric pressure there is the polar opposite of what we see on Venus, where Venus has 92 times the atmospheric pressure of the Earth. Mars has essentially a vacuum there. We wouldn't be able to distinguish it if you just go out and feel it from a vacuum. 0.6% of the Earth's atmospheric pressure, it is so close to a vacuum that it takes a lot of effort to generate that level of vacuum here on the Earth. Now, despite that, it is actually important to note what is there. That atmosphere is not so thin that it can be ignored. And that actually leads to that last little point there. It can be very hard to get to Mars, and putting that little helicopter on Mars took a lot of effort. There's enough atmosphere there that you can't ignore it, so you can't just use thrusters and no heat shield to land. You have to actually use something to slow yourself down through that atmosphere, and typically, yeah, you got to deal with a lot of heat there. But you can't, it's so thin that you can't just use it to land easily. It's an astonishing thing to build a helicopter that works on Mars because the atmosphere is so thin. Really, what we often use to actually land spacecraft on Mars are rocket engines, but you just have to get through the initial slowing down of the atmosphere, getting close to near Mach speeds, going near the speed of sound, as it were, to actually be able to utilize rockets in any meaningful way. But yeah, that 50% success rate, that was thrown on there before the last string of missions that went there. We had 3 very good successes this year that might shift that a little bit. So thankfully, we're doing better as of late on that front. Anyway, back over to our small telescope view. All right. All right. So while we're looking at Mars and Venus here, let's go ahead and check back in over at the other view on our main telescope there. Again, yeah, this is one of those nights where we'd love to spend a lot of time with our main telescope, but we're only ever going to get a few minutes with it. And so while it was great to see that, I'm going to go ahead and actually start closing things up for that telescope. But before I do, I want to actually swing it around so you can actually see it close itself up here. Let's see. This guy should work here. There we go. Let's spin that all the way around. Point it over near this camera, because it's always, oops, I went the wrong way. It has a limit to make sure its cables don't get wrapped. I picked the wrong direction. I had to pick one direction. I chose poorly. All right. Any views of the moon tonight? Yeah, we can definitely swing up by the moon. Actually, why don't we do that instead of closing the dome here? Let's just go up to the moon. excellent question. Let's see. Moon already getting that low? Where's the moon at? Ooh, the moon is at 18 degrees. So yeah, let's get our views of the moon through that main telescope while we can. So if you're wondering where the moon has been, it is hanging out very close in the sky to our conjuncting planets. It's just a little ways above it, up at around 18 degrees off the horizon for us right now. It is a very sharp waxing crescent, which you can tell because we just passed sunset and it is not too far behind it, so it will be waxing. Whenever you see the moon after sunset, it is waxing. It is getting brighter. Let's see, some things are shifting around there. And in theory, if I come over here and hit this button here, let's see, where are we looking here? What is likely unfortunate with our particular view of the moon right now is we're probably looking so close to the moon here that I need to actually go and find my way to actually, which way should it be? It should be down and to the right. Oh, I think I'm getting lucky. There's the edge of the moon there. All right. Now, once again, we are very near that horizon, so we will be dealing with a lot of atmospheric distortion. So that will not be helping us right now. Let's see if we can't get any better of a focus, though. Let's see, if I had to guess, it would be in this direction. Oh. I don't know. Can almost see it. Let's do this. You want to give me my mouse pointer, and let's go ahead and shorten that exposure time as much as we can, because the shorter the exposure time, the less the atmosphere will be bugging us. Increase that gain. Yep, we got a lot of distortion over in that direction there. Let's see, I don't know if we're going to get too much better than this, unfortunately. We actually have a little bit of splitting going on in that view. That's very evident. Yeah, that doesn't feel like where we want the focus. Yeah, I think we're going to have to try and get even shorter exposure times if we're going to get anywhere with this. And just make sure, I'm going to move some things around to make sure we don't lose sight of Venus and Mars on our other telescope. So let's see, let me turn down that exposure even more. We're trying so hard to see anything too close to the horizon. Do our live stacking here. Eesh, that is not helping. Yeah, we are dealing with some really crummy part of the sky here. We are looking right near San Jacinto, and so we are dealing with a lot of air moving over mountaintops, which generally, unless that mountain is nice and smoothly shaped like the majestic Mauna Kea, getting the right mountain, right? Okay, just checking. Yeah, the majestic Mauna Kea, a nice shield volcano, has a nice smooth setup, which makes it ideal for air movement and thus clear skies. Anyway, let's see. Let's go ahead and increase our exposure time because we aren't getting anything better there. While we're looking here, though, we can actually cruise around and see a bit more of this area here. Oh, goodness. Let's see. Which thing am I looking at there? Just a moment. Yeah, that is probably Mare Crisium. If I've got my setup right here. Yeah, I want to say that's where we're looking. Yeah, if we're on a waxing crescent, that is what we'd be looking at. Mare Crisium, which means the Sea of Tranquility will be hanging out over around this area here. This nice big black patch of sky. But yeah, that is around where that would be. Now, why is it worth noting these things? Well, when the Apollo 11 landing happened at the Sea of Tranquility, it's worth noting that it happened not many days after this phase. In fact, what they wanted was something that cast a lot of good shadows at the landing site, because it meant that they could see very clearly how high above the ground they were and the shadows of any obstacles. It likely saved their lives because they ended up coming in an area that had a lot of boulders that they had to actively avoid. They had to take manual control. That is, Neil Armstrong took manual control and steered clear of there. All right, so now that we've got multiple things we can look at here, we can switch over to our combo view and see a few things going on. And let's see, while we're here, let me get this, hit this button, and go ahead and adjust our exposure here. Maybe we can actually see that telescope in that lower left. Sort of. There's a lot of reflection off the window there and other stuff, but you can still see what's going on there. All right. Sort of. That is our view out the Cosmic Office window. All right. Yeah, so this is all the things we're focusing on tonight. We've got a nice crescent moon up here. We've got our view of Venus right there, and Mars hanging out right up there. Working with, again, both this telescope and that little tiny guy right up there. Yeah, Lauren is in the chat there with you guys. She's the one pointing out that transition between the light and dark regions that is really important for casting light and shadow. This area right here is referred to as the Terminator. Yes, definitely predates Arnold Schwarzenegger's character. But yeah, let's see. Unfortunately, again, we are looking so near the horizon, looking right down over those mountains, that it is making all our views very, very unsteady. We've got terrible seeing, as we refer to it in astronomy. Let's see. Let's go ahead and cruise on down towards the southern edge of the moon. Got some nice views of some craters here. Another edge of one of the seas. Double check which one that one is. This guy and this button. See, that will be, oh yeah, that's the one that has that name. Mare Fecundatis. It's spelled Fceunditatis. Yeah. Of course, it would be if you translate it. So unfortunately, I'm forgetting the translation of that one because Mare Tranquillitatis is the Latin name for the Sea of Tranquility. So there's a bit of difference there. Anyway, let's see how far we can go over, down, and around here. Yeah, you can see a good section of that giant toenail in the sky. Yep. Ah, yes. Lauren covering the things I mention and then glance off of. Seeing, yes, seeing is actually how we actually measure the quality of our images, how much things are twinkling. And again, seeing always gets bad near the horizon, partly due to what is referred to as air mass. Air mass is the amount of atmosphere you're actually looking through when you are looking out beyond the Earth. If you think about it, you have a thin layer of air over the Earth. If you look straight through it, you're going to look through less than if you look at a shallow angle. And that shallow angle, having a lot more air in it, gives a lot more opportunity for distortion. And that is why you get worse seeing at higher air mass. That is, again, the amount of air you're looking through. Once again, Lauren saying it in cleaner and more concise language than what I have. All right, let's see. I'm going to switch back over to our little telescope here. Mars is getting a little bit dim in this view, but we're still looking pretty good out there. Let's go ahead and increase our exposure time. All right, maybe increase a bit of gain there. You might notice a few little funny colored points on there. Those are not likely stars. Because we've got our exposure time so high, it's hot out, and I have the gain up a bit, those will actually be what are referred to as hot pixels. They're pixels in the camera that are just ending up extra. They're reading out as being completely bright, even though they aren't receiving light. That happens. Let's see. Ooh, how much time will it take for the conjunction to take place? Excellent question. We can answer that really readily. Back over in the combo view, perhaps. If we're looking at Stellarium, what we can do here is actually lock on to Venus. And when you're talking about a conjunction, you're talking about two objects being near each other. The time of a conjunction, how long it takes, depends on how you want to look at it. You can actually look at a conjunction as an instantaneous moment. It's a point in time that we're leading up to. Now let me go ahead and take this view and see, lock ourselves into an equatorial view here, and in Stellarium we can mess around with time a bit, so let's go ahead and do that. If we're looking here and we advance hour by hour, you can actually see, and because we have atmosphere turned on there, weird things just happened, you can actually see on an hour-by-hour basis just how much these objects are moving with respect to each other. Now, the point of closest approach looks like it'll be around 1 to 2 in the morning, maybe between 1 and 4, but it'll be well below our horizon by that point. If you happen to be someone out in the Pacific, you might have a better view for seeing them even closer together in the sky, but you'll still have a decently good close view of these two objects tomorrow. Again, if we go all the way out to around 9 p.m. tomorrow night, they are still within a fairly good margin there. Let me see. Yeah, they're still on the order of less than a degree separated tomorrow. So if you're wondering exactly how you define the timing of a conjunction, it really does depend on how you're looking at the object. If you're just trying to see two objects close together in the sky, it can take over the course of 1 to 2 days. If you're wanting to see that exact moment where they are at their closest approach, well, then your conjunction is instantaneous. So that is really what we're talking about with comparing those two things. I hope that answers your question. Yeah. Excellent question. All right. So let's go ahead and close that out and jump back to the present. And let's go ahead and re-rotate back to an altitude azimuth setup here. Let's see. As we're looking here, it seems as though our view is not quite right when looking at things. I already talked about how mirroring can happen when you're looking at objects through telescopes, and so we already can see how our big telescope is very rotated, because if we're looking up in the sky at the moon, it's not going to be the upper left part of the moon that is lit. It's actually the lower right if you are in the northern hemisphere right now. If you move further south, this edge shifts and everything is very dependent. But clearly, what we see in the upper left here of our screen is not exactly quite the way the moon looks in the sky. So that's normally something we use the D-rotator to fix, but I'm not going to bother trying to flip that around because that can be all kinds of problematic. In contrast, though, our friendly neighborhood conjoining planets, or rather, planets in a conjunction, those we can mess around with a little bit easier in our software here. In fact, again, let's see. Let's go ahead and want you to be able to see Mars really easily, but those two planets happen to be very different in brightness. There we go. Now you can see at least at point of light in this view here. You can see they're almost completely reversed from what we want. So in theory, if I go and find this guy here, and let's see, I want to grab this. And then what I want to do is not the thing I have actually decided to do. Whoops. Helps if I do the right things. Oh yeah, that's why I can't do it, because it's locked in place. Okay, there we go. Pardon me. There we go. All right, I'm getting where I want to. So now that we're looking at this view here, we can actually mess around with a few things. Though I'm actually going to give up on what I was about to do because we are losing Mars right now. Mars is likely setting right as we speak. There it's going. It's getting very mushed into likely the mountainside here as it is fading from our view. Bye, Mars. Thank you for joining us, Mars. There it goes. All right, back to full view, which means we will be losing Venus very shortly. So let's go ahead and get a good close-up view of Venus and hang out with it for a good while here. There we go. And now we can definitely decrease that gain and decrease that exposure time here. Start to see more than a giant bright object. There we go. Yeah, it's just going to dance around for us a bit. Let's go ahead and I should have switched all the way over here. But yeah, we're going to have only a few more minutes for Venus here, because if Mars hit the mountains a few minutes ago, Venus is going to be very short to follow. Correct, unless you actually stay up really late. If you're counting that instantaneous moment as the actual conjunction, yeah, you'd need to stay up very late. But unfortunately, if you stay up much longer, again, a matter of a few minutes, we're going to lose sight of Venus from this spot. So we will not see the exact moment of closest approach in the sky, but we can see a good amount of it. We were able to see both these objects in the same view of the telescope, which is something that don't often get to do. Let me go ahead and adjust things here. Let's see. Just scroll that up here. There we go. And grab all of this. Okay. Now, there we go. Now we'll probably see something very similar happen to Venus that we saw happen to Mars. It'll fade pretty quickly. Again, we're looking at so much atmospheric distortion. It is just dancing. That is that twinkling that comes from poor seeing, the light getting bent and refracted as it goes through different masses of air. But yeah, we'll likely get to see Venus get even more distorted as it gets right to the horizon. There, I think it might be approaching it right now. Let's go ahead and amp up that gain. I want to see it disappear. Again, we're really watching a rather distorted object, but anyway. Isn't there a probe scheduled for Venus? Yes, there's actually a couple of missions headed that way. Da Vinci Plus and Veritas. They actually want to go and remap the surface of Venus, which hasn't been accurately mapped since the Magellan probe decades ago. And the other thing these missions will do is one of them will be landing on the surface and taking new images of the surface, something that, again, has not been done for decades. And there goes Venus getting nice and stretched out. Let's go ahead and crank up that gain. I want to see it barely disappear. Yep. Yeah, so those two missions should be exciting, but they will not be launching, or they will not be on their way there until 2030. So we've got to be patient. And just like we'll have to be patient until the next time we'll be able to spot these two objects again in the sky. By patient, yeah, you could go, of course, go and see them tomorrow. They'll be pretty close in the sky. They won't be as close as they were tonight, but it will still be close in the sky. Meanwhile, back over at yonder moon, we can actually see a few things going on here. Now, if we're looking at this, we can actually move our telescope around. We might even be able to see a bit more detail with this view than we did with the others, because those were just nearly points of light setting. They just sort of got distorted and faded away. In this view, we might actually be able to see something on the horizon. If I can get the telescope to cooperate with me. Oh, where are you going? I wasn't doing that. Oh, I think the telescope's getting upset. It is getting upset that we are looking so close to the horizon. And so we might not be able to get this one to cooperate fully with us. Let's see, Lauren, I'm going to go ahead and unmute you. I'm going to hop outside and take the small telescope over to the moon.
Alrighty. So yeah, Ron just mentioned that the Russians landed a probe on Venus, and that was actually a few decades ago now. But they got some pretty great pictures. You can look those up and see what they saw. It looked kind of like Mars, actually. But yeah, the heat and atmospheric pressure is so great on Venus that the probe didn't last very long. I believe it was only a few hours. And in a minute here, we may be able to see Eric shifting the view around while he centers the small telescope on the moon. Hi, Ron. And here comes Eric.
All right, I'm back. So yeah, this is our view from the main telescope, which now is no longer cooperating because it's so near the horizon. If I move things around, it's like, hey, no, stop that. So we will not be able to get that there. It's a safety feature, which is very important for keeping that telescope operational. But I got our small telescope over near it. Let's see. Probably need to adjust some things. I thought I was on target. I might need to go take a second look, actually. All right. It looked like it was on target, and now it doesn't appear to be. Anyway, back to Lauren.
All right, I see we have a question about when the next time a conjunction of these two planets would occur. And that is a great question. I'm trying to look that up for you right now. So it doesn't happen all that often because it depends on our view from Earth. And a lot of times these planets could be blocked by the sun, or it could happen during the daytime, so we wouldn't see that then. So yeah, and I see Ron has noted here that the surface temperature of Venus is about 860 degrees Fahrenheit. So that's a bit toasty. And I had just looked up that probe only lasted somewhere between 23 minutes and 2 hours. So they snapped a couple pictures, and that's about all they had enough time to do. Oh, thank you, Ron. He found that the next conjunction is not until 2035. And let's see if what's Eric has going on.
All right, I am fighting with that little telescope. I feel like, oh, I know I can't see anything. Because I'm still zoomed in from when we were looking at Venus. There's the moon. That helps. All right, we don't need that kind of gain here. There we go. Now, of course, things look a bit clearer with our smaller telescope with this. There's a few reasons for that, not the least of which is the fact that we aren't as zoomed in, so the distortions aren't as dramatic, though there are actually some effects of, of the larger aperture capturing more distorted light. Excuse me. All right, so this is a nice crescent view of the moon here, which is always a great thing to get. Now, normally we would have, if this was Swoon at the Moon, we'd have a lot of extra stuff for you here, but we were so focused on other things, I didn't actually get those slides made. So, let's see. Yep. Yeah, once again, that is Mare, what did I say? Was Mare, yeah, Crescent. Let's see. Yeah, so I do have a moon phase map available, but it's kind of not today. So perhaps we can actually mess around with that here for a minute. Let's go ahead and let's see. We go over here. Yeah, no, we completely lost the other one up there, but in theory, I should be able to push this button. No, not that button. That button didn't do anything. This button. These buttons aren't doing anything for some reason. Ah, there it is. All right, so our view here is not the exact phase we're looking at, as is obvious, I hope. But now you can see the actual comparisons of where things are. And again, our view is rather rotated here. Now it actually seems rotated by a good chunk of what would be around 180 degrees. So I want to say, yeah, it should be rotated is what we're seeing. Always a interesting thing to actually go and say, is it rotated or is it mirrored? And figuring that part out is always a challenge. So yeah, back over to I want this guy, and I want to transform by doing this. So that's actually close to what it's seeing, what it's shaped like in our sky right now. How can we tell? Well, once again, if we pull Stellarium back up, we can actually go and compare our view there with this view here. Look how similar those are. All right. Always a fun thing for me to see simulation actually match reality. It's very useful in general. And of course, flipping it in one does not flip it in all. So let's go ahead and flip that one around. There we go. Okay. Now, when I went out there and evaluated where the small telescope was and looked at some things, it looks like from that position, Venus and Mars didn't drop behind the mountains. They actually hit the observatory wall. Again, if we're looking out at the view down here, there's a wall that stretches right there. And in order to get a very good view towards the west, we need to position the telescope in just the right spot. And it's always a question of whether or not something's going to actually make it to the mountains or if it's going to hit the wall. In this case, it hit the wall. All right, back over to our nice, lovely view here. Yes, yeah. When we're looking at the seas of the moon, again, They are the low-lying regions of the moon. This is the main one we can see right now, Mare Crisium. It is an area that is lower lying, and at some point in the moon's past, it actually filled in with lava, making a nice smooth-ish, relatively speaking, surface that has a lot fewer craters in it than the lunar highlands. And so it was actually a bit thinner crust for a while before lava filled in there. And it is actually something that it is something that happened a long time ago, but still not so long ago that we don't see a difference in the actual concentrations of craters. And yes, answering Steve's question, Stellarium is available to the general public. Again, that is this software we've been using here. This is actually entirely free. If you just search for Stellarium, and it looks like all right, we got some links in the description, of course, for these two things. Yeah, Stellarium is great for looking at things from the ground. Again, with the right setup, you can actually even put things in like a nice view directly from the observatory. It takes a lot of effort to make these views, but you can get a nice custom landscape there. And the other software we were using earlier was Space Engine, which is this one here. And Space Engine is phenomenal for a lot of different things. Again, if we actually want to see how that nice line of things that stretch right from the Earth out through Venus, off all the way to Mars, that line right there, well, we know the moon is going to be near that line as well. So if we go back into Space Engine and fly back on down to the Earth, as long as I don't crash into it or fly by very fast, yeah, we can see roughly in that direction we were looking. Oop, flew too far. In that direction we were looking, that yellow circle there is the moon's orbit, with the moon hanging out right up here at the top of that line there, right there. And again, in Space Engine, we can actually, again, I can slow down and not try and do things too fast. There we go. We can actually drop on down and see all of the objects we were looking at very nice and near each other in the sky. And so here we are way outside the moon's orbit. And if we adjust our field of view, we can see all four objects in question: our home, the Earth, moon hanging out beyond, and then Venus and Mars beyond them. So Space Engine is a phenomenal piece of software, and again, developed by just like a very small team, originally by one person, and originally offered for free, but they kept advancing and adding a lot more to it, so they put a relatively small charge on it. I want to say it's around $25. But yeah, it's a great piece of software. Not sponsored, just love it. Anyway. All right, let's hop back over to our small telescope view to see how the moon's doing there. We can go ahead and adjust our view here. Make sure we keep things in line here. We have a while yet before the moon will set, but nevertheless, we will only be going for a little while longer here, because we were here mostly for that conjunction, which is, well, beyond our scope of seeing. But yeah, let's see. So yeah, we will likely be wrapping up here shortly. Let's see, Lauren, is there anything else we should be covering before we start wrapping things up?
I think we covered a good amount of the solar system today.
Yeah, we definitely saw a few things here. Nice crescent moon is always a great thing to wrap things up with. So with that, I guess we're going to go ahead and call it a night. So want to say thank you to everyone for being here. It has been a lot of fun hanging out with all of you, and we hope that you guys have enjoyed your time here. And we also want to, again, give a thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're able to offer events like these, and we are going to hopefully be offering a lot more in the near future. And of course, I would be remiss if I did not thank Lauren Zuckerberg, our observatory coordinator, as well as a number of our docents here in the chat for all their wonderful questions and intentional guiding through this. It's always great to see all of you here, and I look forward to seeing you all here on site very, very soon. We are on our way to that, and it won't be long before we actually get back to stargazing here. So once again, thank you, everyone. Hope you had a wonderful time, and remember, keep on looking up. Good night, everyone.